Hi, this is the topic 3, molecules and bonds. So in our previous topic, we talked about atoms. And atoms, we mentioned that atoms, except for some atoms like noble gases, who by itself has all their electrons being paired up. For the rest, all the rest of those atoms, they have valence electrons, so they need to pair them up. So basically all atoms except for noble gases, they exist in the nature by pairing up with other atoms. But not every pairing up make up a molecule. So the most accurate definition of the molecule is that a molecule is the smallest particle that carry this substance's all the physical and the chemical properties. This is the most accurate, but also difficult to understand. But one way to understand it is that if all the molecules are pairing up by a special connection called a covalent bond, and then this we call it a molecule. But it doesn't apply to all of the cases because its only exception is the noble gases. Noble gases is one single atom is a molecule. And next, let's first talk about what is a bond. Atoms join together by special force of connection or attraction. This attraction is called bonds. Bonds may have different types. One type is, let's talk about call it ionic bonds. Ionic bonds are the attractions between different ions carrying the opposite electric charges. And for example, the say cation and iron. You have one ion is positive, the other ion is negative. They attract each other. This is called an ionic bond. An ionic bond does not make a molecule. No, it doesn't make. Why? Because you may have something connected, all joined together. But you see, all of those things join together, these ions join together, but they don't make this joint is not good. It's more like this. The ions join together follow special structures, not randomly. But anyway, you see this substance, you cannot find a fundamental or basic units. Says one unit that carry everything. And then lately, when they dissolve in water, they just separate it into ions by itself, free ions. So this is not a molecule. A molecule is that there's some special items A join with item B, and this join like a marriage. They do not easily to be separated. They are special to each other. This whole thing we call it a molecule. And then how this kind of item can join together? This join we call it sharing. For example, you have two hydrogen ion, each one of those has only one electron in a shell 1, and they want to pair up. And these two hydrogen ions join together, and they share their electrons, one pair electrons. And this sharing electrons, we call it covalent. Covalent bond, that's only when the atom join up by covalent bond, you can make this kind of molecules here. This two covalent bond is made of the same H and H. You can also have O and O. In O and O, in these two, they share two pairs of electrons. In both cases, you see this is oxygen and this is oxygen, and this is oxygen and this is oxygen. those oxygen, this is hydrogen, and this is hydrogen, and both of those have the equal power of attracting electrons. So the electrons basically this circulating this two and circulating this two equally. In the surface of this molecule, there's no charge, no electricity charge at all on the surface. And then we call this a nonpolar molecule, which means no charge at all on the surface of the molecule. And then accordingly, you see we have nonpolar and we have a polar. What is a polar molecule? For example, this is an oxygen big, and this is a hydrogen here. And hydrogen is small. So each hydrogen will share one pair electron with the oxygen. And then oxygen has a much higher power of attracting electrons here. So the electron stay here more often than here. In this case, since electrons stay here more often, here in this side, in the oxygen side, it has a negative charge. And on the hydrogen side, it has a positive charge. And this charge is not great. It's minus 0.6 something. And this is positive 0.3 something. Not a full charge, only a positive charge, only a partial charge. And this, now you have an electron charge gradients here, and this we call it a polar molecule. Water is a typical polar molecule. And we have other polar molecules which we'll also discuss in the slides. And then you think about this is a polar molecule. It's a water molecule. It's a polar and positive, negative, positive. And again, you consider there's another water molecules. Negative, positive, positive. And this is positive, negative. They can attract each other. And this attraction is weaker than ionic bond, but still there's pretty obvious attraction between here and this. We call it a hydrogen bond. And this hydrogen bond exists a lot in the water. In fact, in the water molecules, many water molecules attract each other here, another one, by the hydrogen bond. And this hydrogen bond between water molecule contribute a special property of water called coherent. I'm not sure it's correct. Coherent property of water means the water molecules attract each other. And then this coherent property contribute to the water property. Like, for example, if you see a water droplet, they tend to stay by itself. That's because all water molecules try to attract each other. And then this property that water molecule tend to stay by itself, we call it surface tension of the water molecules. For example, if you have balloon, there's a balloon. If you have filled water, gradually it collapses to each other. These two walls collapse too. That's because water molecules tend to attach to each other. They call it surface tension. And then for the water molecules, this is a water molecule, oxygen, hydrogen. They not only can attract each other, they can also attract to, for example, I'm sorry, this is wrong. Okay. It's not only attract to each other, negative. But what if we have a sodium ion? Sodium ion can be attracted to the water molecule, and there's another water molecule attract here. So another one attract. So if you put, say, sodium ion, and this is chloride ion, and chloride ion will be form another hydrogen ion with water molecule. And this is contribute to the water, another property of water, dissolving. Water is a perfect solvent to dissolve many things. Here, the salt can be dissolved in water, all because the ions are separated. The salt substance are separated by water molecule into single ions. By the water molecule form the hydrogen bond between water molecules and ion, and other polar molecules, and can also be dissolved in water. All because of this water molecule that is forming the hydrogen bond between the water molecules and the polar molecules. And so this the hydrogen bonds between water molecule and the solute contributed the capability of water to dissolve other materials inside the water. And this is the major function of water in our body, to serve as a solvent. Water is a perfect solvent in our body. And another thing is that, so you can see, so what kind of molecule can form a hydrogen bond with water? Polar molecules. Polar molecules form hydrogen bond with water. And this property that the polar molecule can form hydrogen bond with water, we call it hydrophilic. A hydrophilic molecule is a hydrophilic molecule or hydrophilic substances are all of those that can form a hydrogen bond between water. All polar molecules are hydrophilic molecules. And please keep in mind, not all hydrophilic molecules can be dissolved in water, because in some cases, hydrophilic molecules, they themselves form much stronger hydrogen bond between each other. They cannot even be separated by the water molecules. So basically, let's say this, only hydrophilic molecules can be dissolved in water, but not all hydrophilic molecules can be dissolved in water. And on the other side, what about nonpolar? Nonpolar molecules cannot be dissolved by water, because there's no hydrogen bond with water at all. And then this kind of substances we call it hydrophobic. And hydrophobic, for example, oil, fat, all of those are hydrophobic molecules. They exist in our body. But they also exist in our body. But how our body can transport them, can store them? These, for example, these are droplets. They are dissolved by another thing called there's so many things. Okay, good. This we call it surfactant. A surfactant is a molecule. Where is it? I cannot find it. Okay. So, surfactant is a molecule that has hydrophilic head and a hydrophobic tail. It has two sides, and this side, hydrophilic head, will help the oil to be the hydrophobic tail will attach the oil and basically coating the oil with the hydrophobic head. Basically, it helps the oil to be dissolved in water. This is a special molecule in our body to help dissolve the oil. So this is so far about the hydrophilic, and a special molecule called surfactants. And later on, let's say another thing. This is a water molecule. A water molecule, and especially two water molecules joined together, there's a very low chance that one lose one hydrogen to another. And this, in some cases, we just write as this one, hydrogen ion. And hydrogen ion in regular pure water is only 10 to the 7th, 10 to the order of negative 7th. But this is the concentration of hydrogen ion. And hydrogen ion concentration is a very important parameter. It's so important, people even invented a special measurement of the hydrogen ion concentration called pH. pH is calculated negative log hydrogen ion, which means if this is 10 to the minus 7, then pH equal to 7. A pure water has a pH of 7. And this, a pure water, we call this neutral. It does not particularly strong in either donating or receiving hydrogen, in a hydrogen ion, or sometimes we call it a proton. And when the pH is less than 7, this solution has a strong capability of donating hydrogen. We call it an acid. And the pH is more than 7, it is also a base. So acid and base are also important in many reactions. In many cases, in human body, our blood is in a very narrow range of 7.35 to 7.45, which is considered neutral. If you change the pH, the body may not work at all because this is acid or strong acid or strong base will destroy the hydrobonds in the protein. Protein, later we learn at the beginning, protein is a long linear, and then it folded in a small, regular shape. And this shape, right, like say this special shape of protein. And then this shape is maintained by special hydrogen ion. And then this acid or base will break it. And when protein structure change, no longer function. That's why our body need a special structure. And especially the base also can break down the fat. So with a strong base, we normally use base as a cleaner. And that's because they can remove the grease, oil, and the fat. So that's the pH, acid, and the base. And to maintain a special, let's see, some new space. Here. Okay, I have new space. For the special say, to maintain a special range of pH, in our body we have a special in the blood. There's something in chemistry we call it a buffer system. A buffer system is that you have A and B, they can be converted to each other. If you put more acid, A become B, or put base, B become A, etc. In the chemistry, this is a system that can maintain a solution within a special range. But early people thought this is contribute a lot, especially bicarbonate system in the blood, because people find the bicarbonate a lot in the blood. First, people think this contribute a lot to maintain the blood, but further studies showing that our body is more rigorous or robust in maintaining its own pH range, and most of the thing is the kidney. The kidney play a central role in controlling the pH of the body by get rid of hydrogen ion and sustain bicarbonates. In our body, the bicarbonates, although itself is a buffering system, but in most cases, the bicarbonate is used as an alkaline to neutralize hydrogen. Why we specially neutralize hydrogen? Why the body specialized in get rid of the acids and maintain base? That's because metabolism generate in a lot of acid. So when the body is actively metabolize things, it generates a lot of acids. And the body's major task Although it's two direction, also acid base, but major task is remove the acid, maintain in the base status. But this status cannot be done by just just drink some alkaline water. It cannot help. Maintain a healthy kidney, a healthy gut will be more helpful. And lastly, we talk about another special bond, CH bond. A CH bond is so special. CH bond firstly is nonpolar because carbon have a similar power in attracting electron as hydrogen. So this one is a polar, and one carbon can connect to 4 hydrogen. This is called methane. This is a nonpolar molecule, and any molecule that contains only carbon and hydrogen is a nonpolar molecule. And not only this nonpolar molecule, a CH bond is also another name. This bond called the bond of life. The bond of life. Why we call this? Because this bond in the current status is only found in life. It can be only generated in the form of life. And any molecules that contain the CH bond, we call them a organic molecule. So in the first topic, we talk about property of life. There's no special element in life, but we do have some special molecule in life that called organic molecule that contain a CH bond. But this is not really a property of life, because in modern study, we found that even in the deep space, because of the radiation and here and that, they can generate organic molecules, but they are still not life. They have to still put in the right order to make a life alive. And in this topic, we also talk about a little bit about some of those. In next topic, we mainly talk about the organic molecule in life. In this class, we just introduce some of those major groups, very common in life. One of those is OH. This is called a hydroxy group. This is a polar group. And then, for example, CH. This is the this is alcohol. This is the ethanol, alcoholic drink. I mean, this is the wine. And then another one is this is called a carboxylic group, and this is an acid. Many organic molecules carrying this group, we call them bioacid. In many some common thing, including this one, like say fatty acid. Fatty acid contain a long carbon tail plus this carboxylic group, and this is acid. And what else? Another thing is amine group. Oh, no, not this one. Only 2. Amine group. If a carbon having both an amine group and carboxylic group and something else, this we call it a amino acid, which is the basic unit of proteins. Something, this is not really a group, but we talk about here. A carbon linked to oxygen with double bonds. If this existing in the middle of the organic organic molecule, this is called a ketone. If this on the edge of the organic molecule, call it aldehyde. Both is sugar. Not all of those are sugar, but actually sugar can be either of those. Glucose is an aldehyde sugar, and fructose is a ketone sugar. So this is that's all for the molecules and bonds. Is only brief. Please make sure you read through the slides and review the summary. I don't cover all of those, and only make the most important thing in this. Only this explain the most important thing in this class. Okay, so that's it for this one.